let's see how to work with variables and functions in Theano. Before starting, I will need to import these 5 things. I will be importing numpy, in, function, shared, and Theano tensor. So in Theano we have 3 different things. We have shared variables, and we have constants. Ideally, shared variables will be used for maintaining a global state, such as, for example, let's say an accumulator that tracks how many times we call a function, or maybe to update a global counter, or specifically if we want to work with data science and deep learning, to work with a neural network that has certain weights that we want to update in each iteration. Variables will be simpler, they will be used for internal calculations, and constants will be self-explanatory. They will be just used for assigning a value that cannot be changed later. So the way we define shared variables in Theano is by calling the shared function. It will require as an input any numpy object that we want to pass. In this case, I'm just passing a 0. And the type here will be inferred. Python will say, well, this looks like an integer of 32 bits. So this will be stored as an int 32. I could certainly be more specific about that and write, for example, this thing over here and define an integer of 64 bits, for example. But anyway, that's not relevant for this example. The other thing is that when I execute state, and I'm declaring the state here, and see what's inside state, I can see it's a tensor type, but I cannot see what's inside. So the way I see what's inside is by calling state.eval, which now I can see it's a 0. That's good. Now let's see a variable. So in this case, I will be defining a scalar variable. It will be defined as increment, and it will be an integer of 32 bits. So if I execute this and see what's inside, I do int.eval. This won't work. This throws an error because this is a shared variable. So I cannot see what's inside. It will only exist when the function is called. And this is an important thing. All the functions here in Theano will have a preliminary declaration containing the variables that we will use. And then we'll have the function that will be interacting with those things. All these variables that we can put here, for example this one, will be symbolic expressions that will only have a value assigned when this function gets called. That's the only place where they exist. So that's why I cannot see what's inside inc. So once this is ready, let's just do a clean run and do accumulator 1 of 10. So I got a value, and what was the logic here? So the logic is that this function has 3 parts. It has an input, an output, and something that gets updated. This one is optional. So in this case, I just passed 1 parameter. I could have passed 2 of them like this, or as many as I want. And in this case, I'm just outputting the same thing, just 1 value. I could be outputting more things. And the way the mechanics work here is like this. I pass, let's say, accumulator 1 evaluated at 10. So a 10 gets passed here, and it gets transformed into this thing that we have here, a t.scalar type. So this gets transformed, and this gets outputted, so I get a 0, because that will be the current state. And then it gets updated, and it gets updated like this. 0 is transformed by 0 plus the value that I pass. In my case, I passed 10, so this will be a 10, that will be replacing a 0. So I run accumulator 1, and now it's have this value. I can see what's in state now, so state.eval, this will be 10. I can call this again accumulator 1 of 90, and now I will be getting a 10, and if I do state.eval, I will get 100. So that was quite easy. Let's see a different example. I will be passing a vector here, and I will be just pulling 1 element from that vector, and the function is pretty similar. So I do accumulator 2, and I do numpy dot array 10 91. So I get the first element. Now let's do a more complex example. I will be defining a different function here. It will return three things. It will return two elements of a vector that I pass, plus a parameter that is optional. And this is why I'm using the in function. So it has a default value of 1, but if I want to pass a different value, I can. And it will be replaced here. So let's call accumulator3 numpy.array, let's say 91, 190, 89. So accumulator3. So this is what I get. The first value, second value, and the W value, which its default value is 1. Another way would be to do this, and then, for example, a 10. So it got replaced. It's important to realize here that the way I'm treating W is as a float. So you can see that when I pass the 10, you can see it's 10 dot something. So that's how I identify it. It's treated as a float. And finally, we'll see a much more nicer example. This is certainly more realistic. Let's assume we get two vectors. Both of them are integers of 32 bits. And I would like to multiply all the elements in vector 1 by all the elements in vector 2, and then I would like to sum that result. That doesn't seem to be so hard. But the result from this operation would be not a number, any number, it will be something else. It will be an integer of 64 bits. So let's try to run this and see what happens. Bear in mind that in this case I will be updating my wi variable, my w variable, by this I. That will be the result. So if I run this again, you can see that I have a problem right now. If you look closely, you will see that an update must have the same type as the original shared variable. So that's interesting. It seems that shared is being treated as an integer. You can see that here. It's being treated as an integer of 32 bits, and the result of this operation will be an integer of 64 bits. So that's interesting, and that's why I mentioned before that sometimes we need to be more specific about the shared variable that we want to have. In this case, I am just saying, well, let's define shared to be an integer of 64 bits. Now let's run it again. This will run. So this is what we wanted. So now you can see that I have accumulator 4, and this will require two arguments: numpy.array 10, 18, numpy.array 11, 189. So that's the final result. That's the multiplication of 10 by 100 and 18 by 189, and the sum of them. And now let's see if this variable was updated as we wanted. So we do this, and we should get that obviously it was updated as we wanted.